All right, so first off, thank you so much for having me. This has been kind of a fun talk to put together because at this point, there are so many different pieces of infrastructure that we could use to try and do multi-messenger follow-up that the first thing I actually have to say in the whole talk is if I miss your favorite one, I'm very sorry. So I've got one real slide of motivation. I don't think this group needs a huge amount of it per se, but the motivation is that there are a lot of overlapping efforts in both the software space and the observational space. So this is a little movie that Gotham Ryan and I made showing the follow-up of this particular event. This is GW 1908-14. And you can see that each one of these tiles corresponds to a pointing of a given telescope. Now, assuming that you end up, there we go. Assuming that the counterpart, the gravitational wave, was in one of these two sections, you might be okay. Those are the highest probability regions. But there are many areas inside the probability region that are close to zero, but maybe not all the way zero, that just never get observed. There are also, especially like on this lower probability region, there's very few observations that happen. While, we'll see if I can play this again. On the main probability peak up here, there's many, many observations that all overlap, taken at the same time, similar depths. And at the end of the day, probably won't tell us much more. So this is my initial slide saying that coordination is really key to the success of multi-messenger astronomy. So what I want to do is I want to walk you through a full working example of what it's like to first receive the alert and then talk about platforms that have been developed kind of at each stage of the observing process. So we start with the most basic thing is a gravitational wave event or an ice cube neutrino event occurs, some kind of multi-messenger event occurs, and then we want to start following up. So first off, we have to have some way to know about this. There's two different systems that are currently set up that are carrying the LIGO alerts, and we're currently working also with the ice cube group, but we're not all the way there yet. But these events are carried over GCN, for example. So this is now the general coordinates network, used to be the gamma ray coordinates network. I think we're going to hear a talk on some of the upgrades to the GCN later tomorrow, so I won't go into too much detail on that. But we want to be able to connect to some kind of stream. A lot of the technology that we've been developing are based on these streams, and the technology, the specific implementation of those streams has been Kafka. So a lot of these things, so you can see over here, GCN has adopted Kafka. I'm going to talk a little bit more about SIMA in just a moment. But the first thing we need a connection between all these things. GCN has done a great job at setting this up. I am also part of a group called SIMA, the Scalable Cyber Infrastructure for Multi-Messenger Astronomy group. I've become the product owner for the things that we've produced. And at the heart of what SIMA has produced, it is this stream system called Hopscotch. This is the second stream that carries all of the LIGO events, and it's the second place that you can also listen and look for these, or set up basically a listener to these to trigger your next set of observations. The idea is, though, we want Hopscotch to be even more general and to not only carry things about multi-messenger astronomy, but we want it to be a general use, basically the backbone of communication between several of these different intertwined systems. So because of that, there's a lot of things that are going to be going down the streams. And so we've adopted this pub/sub or publish subscribe model, where you don't have to listen to the whole fire hose of events that are coming down the stream. You can choose which of the topics that you're interested in, listen to those, and you can set up individual responses based on any of those. We're also aiming to start to congregate a lot of this other information in similar ways to the Astro-COLIBRI with other existing services, things like GCNs, transient name server, astronomer telegrams. And so we're trying to pull all of these together into a single place so that we can start to use them more effectively. And we also, as the number of messages increases, we need to have more capabilities to search for things programmatically. This means we need more machine readable content in all of our messages. But the community has also shown that we want some availability of human readable information. And so we've worked quite a bit to try and marry the two so that we've come up with these hybrid messages. So a little better picture of what I'm trying to say here is this hopscotch Kafka stream, and I'll give, and we can talk about the database in Hermes a little bit later. But it acts as a central connection. It's a set of pipes between all of these different pieces of infrastructure that we have. And even on this diagram, which is not even remotely complete, you can already see how complex following up, say, a multi-messenger event actually is. So, up here, we have our multi-messenger triggers. This could be IceCube, this could be LIGO Virgo Cagra, or, a variety of other instruments. And so first they have to get their information to the community, so they send a message to Hopscotch. There are several other automated systems that are, say, the Antares brokers, which may be then connecting to other observatories and surveys like Rubin, which is getting ready to turn on. It might connect to, say, individual users who are, say, using Astro-COLIBRI and what to do follow-up on that. We've also developed something called the TOM Toolkit, which I'll talk about in a little bit, which is another way to connect other outside telescopes for follow-up. It's going to connect to the treasure map, which is going to help with visualization. And then we want to connect, we want kind of a bidirectional connection with NASA GCN so that we can both report what we find, but we can also do space-based follow-up as well. So at the heart of this, like I said, it's really about messaging. All right. So we have an event, but now we have the secondary problem is, do we follow up this event? Everybody has a finite number of resources. Even if that resource is only time as a human being, we have to make a decision on what we want to follow up. And so this is an example of some of the tools that we can use to make this decision. So that it's going to blink back up in just a second, or actually went by very quickly. First thing I showed you there is the treasure map. And so that shows a nice visualization. I'll come back to that in a second. And then information about the event from GraceDB, which is the LIGO Virgo Cagra provided service. So one of the things we've been developing, and so this in particular uses the TOM Toolkit, is a way to collate all of this data together. You need information about, say, the probability regions, so that you know how far away it is. You know what telescopes you're going to need to get to a specific depth. You need to know which electromagnetic candidates have already been discovered in the region, so that you're not just repeating yourself and repeating observations for nothing. But perhaps if you recognize some of these names like HD, this might be a star. And so you want to retire it. Now, once you know which targets, you want to be able to then trigger other observations, which is what it's showing now. It stopped. All right, good. So, which you can do from a page like this. So there are kind of many steps in this follow-up process. But really the first thing we want to be able to do is organize the information. And so I would be remiss to not show a slide talking about Astro-COLIBRI and how it fits into this ecosystem. And I think one of the really strengths I've seen of this platform is that it pulls all this information from many disparate sources together, and it allows you to use or to start making informed decisions about how we want to do follow-up on a particular event. I also want to applaud them and say it also behooves the rest of us that technology's changed in a lot of these messaging techniques. The cell phone has more power than a lot of supercomputers did, right, back in the day. Technology's changed both, in hardware, but it's also changed in software. We no longer have to be sitting at a computer terminal to be able to trigger observations. We no longer have to be sitting at a computer terminal waiting for something to happen. Instead, the mobile app and on the web, we have a huge amount of power and a huge amount of development and libraries that make it possible for us to do science in kind of a new way. So I think it does behoove us to definitely use some of this new technology. All right, so we've now been given an alert. Let's pretend it's a gravitational wave alert just for an example that comes down a Kafka stream, either via GCN, via hopscotch. You've received this alert. Perhaps Astro-COLIBRI has buzzed in your pocket to say that, oh, there's a new event. So now we need to start making decisions if we want to follow this. So there are many, many external services that can tell us more information about that. And I want to point out two things. So one of which is Astro-COLIBRI has done a good job at connecting some services. But there are so many of these external services that it's actually really difficult to keep up with all of them. For example, BLAST is a new one that we've started supporting in SIMA. BLAST is a service to query information about individual transients, host galaxies. And so what I'm honestly hoping the most out of this workshop is I want to start being able to connect some of these different pieces. So, perhaps if you're interested in things like this, I'd love to find ways to hack together some of these and connect some of these different pieces of infrastructure like BLAST. All right, so we've got information about the event, and now we want to decide, okay, how are we going to follow up? Well, in the good old days, or maybe not so good old days, you call up your friend on the telephone and say, hey, I hear you've got this telescope tonight. Would you mind observing this thing? We've moved a little bit away from that in some respects, but not always. So one of the things we've developed has been this thing called the TOM toolkit. So TOM stands for Target and Observation Manager. Basically, it creates a database plus individual Facebook pages effectively for your targets. There's many pieces of visualization that end up in this system, making it easy to decide to both search for candidates, which is what I'm showing here. You can add new targets here. And then at the end of the day, this TOM toolkit, this TOM will connect to observatories. And those observatories can then be used to follow up whatever you want. We're already at the point, and Ruben is only going to exacerbate this, where it doesn't make sense necessarily to have a human being looking at every single target and saying, okay, I want to trigger follow-up. I need to call somebody. It just doesn't work anymore. Instead, we need automated systems like queues and APIs to set or to be able to trigger these observations without having to go through a human person as an intermediary. And so that's one of the things we've developed here. And I'll talk a little bit more about some of the other telescopes, but you'll notice that this has submitted an observation to LCO. LCO is near and dear to my heart, which is Las Cumbres Observatory. Partially near and dear to my heart because they pay me a paycheck. So this page directly interfaces with our systems, and it allows you with just a few clicks of a button to be able to submit observations to go on our network of telescopes. So I have to give, this is our standard Las Cumbres slide. In case you haven't heard of us, Las Cumbres Observatory is run out of Santa Barbara, but we operate a network of about 25 robotic telescopes around the world. Our aperture classes are generally on the small side, so we run a series of 1 meter, 2 meter, and 40 centimeter telescopes. All of these telescopes, though, are robotic, they're robotically scheduled. And so we actually don't even have people at any of them. They're all on established observatory sites. But we really don't have any of our own LCO people anywhere except Hawaii and Australia, where our 2 meters happen. But everything is automatically controlled robotically. Now, on the 1 meters and the 40 centimeters, we have a series of imagers. On the 2 meters, we have low resolution spectrographs. And then wherever you see this NRES little logo here, those are where our 1 meters have fibers connected to our shell spectrographs. So we can use telescopes like these to, say, search for an electromagnetic counterpart, or once a counterpart's been found, we can do very, very rapid follow-up. We are spread in longitude and latitude for very specific reasons. Makes sense. So in latitude, we want to be able to basically cover both the north and the south. We always want to get full coverage of the sky. In longitude, we want to be able to always have a telescope in the dark. And so both of these make us really ideal for doing time domain follow-up. And one of the things that we've learned about this, as we've produced these telescopes and as we've operated these telescopes for about 10 years now, we began our version 1 operations in 2014, is that there are some common things that make observing on other observatories in an automated fashion much easier. One of the big things is a set of APIs that you can hit via just their web endpoints, so just via the internet. And then you can make requests for observations on this network or on your telescope. Also, the telescopes really, it helps the telescope anyway if they're Q scheduled at least part of the time. Interrupting classic observation versus Q observations is still a little bit of a contentious topic, and it's a little difficult. So this mode of operation works a lot better if you're at least partially Q. And then we also, at LCO, we have preferred robotic operations, but we understand that it's not really feasible. So for all telescopes are going to be able to do that. With all of this in mind, we created something called AON. So this is the Astronomical Event Observatory Network, which is a collaboration between telescopes. So the original partners are Las Cumbres, SOAR, and Gemini. And we set up a common set of APIs so that any one of these telescopes can be triggered via an automated system, much like ATOM that I showed you briefly before. SOAR operates something like 1 to 2 nights a month in AON mode. And so the rest of the time it's constantly scheduled, and it does just exactly what it's always done. But for those few extra nights, the information comes through and it runs through the same scheduler that Las Cumbres uses. And then instead of having a robot control the observations, you have an observer on site who takes the output of that schedule and then enacts it and just continues through the night. Gemini is basically fully Q mode now. And so that didn't require so much of that. So it was it was already operating in that mode. So it was a very natural way to implement. But I'm also happy to mention that we just recently got funding from this last National Science Foundation call to extend our AON network into what we're calling AON Plus at the moment. And this has the goal of doing a couple things. One of which is we want to build a full library of functionality so that basically any telescope that is interested can work on a common set of tools, including APIs, things, and even observation planning tools like we're kind of showing down here, so that users around the world, and irrespective of how many or which telescopes you're using, can have a similar feel and they understand how to trigger the telescope. We're also taking some time and we're increasing the number of partners that are going to be AON compatible out of the box. So we're going to include CFHT, several of the Noir Lab telescopes, Skynet, and and then including radio observations as well. So we're trying to go beyond just optical, which I've spent most of my time implicitly focused on, but we're trying to increase wavelength coverage as well. So again, if you're interested in hacking this week, this would be another, and you have a small telescope, or I mean, not even a small telescope, but a telescope that may not be connected to automated things, I'd love to talk to you about it. So that's one piece of the observatory thing. But the other problem that we have to worry about is right now, it's often difficult to understand or to know off the top of your head which observatories are available. Does anybody know if Gemini is available tonight? Anybody know what instruments are off Gemini tonight? These are questions when you're thinking about triggering things, right? And so the other project that we're just getting started and off the ground, and we just got funding as well for the NSF, is something we've nicknamed Heroic, which is of course a terrible backronym that says hop and scotch enabled real-time observatory information and coordination. And so this is a system, again, that we're just beginning to build. And the idea is just like Aeon Plus is bringing together these different APIs, we're going to be providing an intermediate layer that is going to then be a place that people can go see the status of observatories. This can include instrument outages, weather, and a variety of different things. And so this is a little mock-up of what we've got, what's going on. So for example, this is, is LBK on and observing multi-messenger events? And then, if your schedule is actually part of the automated system, say of Aeon Plus, you can even see who's got what night. But it doesn't have to be that way. That's just this is kind of just a mock-up. But then it also can tell us something about the weather and, what all these different availabilities as well. So our goal is to make this, again, a system that we get as much buy-in from the community as possible. If we don't start connecting some of these pieces, we don't get buy-in to these things, it doesn't matter how pretty of an interface we make, it is still not going to do anybody any good. All right. So multi-messenger event has come in. You've decided you want to trigger it. How do you decide, say, how do we then decide if it's worth following up or trying to coordinate with somebody else? Well, the first answer to that is we use something called treasure map. Now I'm going to only have this like one little spiel about this because Sam is going to tell us much more about this later. But treasure map is a system that's designed to help visualize and coordinate observations. So this is the example of the visualization. You might be able to go look at this and say, okay, I have, the rest of this night on a particular telescope. Where is it the most worthwhile to go look for something? And when you do your observations, the telescope has an API to submit where your telescope is going to be pointing, and it also to check and see who's pointing there. And so we want to build more coordination between some of these different projects as much as possible. Treasure map is a great example of trying to really pull the community together and help them coordinate to make sure that the full area gets observed and not just in one little batch. Those are all the different observations of that particular one. The very well observed event. Again, I showed you the movie, the original time. We are now, like I said, we are now in an era where it really behooves us to start coordinating in a very serious way. All right, so we have treasure map. Say you find an interesting target. How do those get reported back? Well, there's kind of two mechanisms for that. One of which is time domain brokers. So this is a particular one I picked is Antares, and this is reporting targets discovered by ZTF. Again, there are many, many flavors of this, so I'm sure if I haven't picked your favorite one, sorry. But so there's a couple of different ways that targets can come into these. but mostly these come from the larger surveys. So say ZTF does tiling on a non-localized event region. It then feeds back all these new candidates, and then you can either pick to follow one up or vice versa, you can try to report one. The brokers are supposed to be pretty automated systems. And so again, they follow a stream-like messaging system. So in principle, you can set up a listener to say, every time I get some interesting event, this broker can send me a text message, and or the piece of software I write can send me a text message, and then I can go trigger my telescope for. Secondary piece of reporting these targets back is have to have identifiers. So we can identify everything by coordinates, but that's not really the best way to do it. So instead, we've agreed on using the IAU's naming, or the IAU Supernova Working Group system, the transient name server. So this is a system that then gives names, designations to all of our new targets. I think we have a talk on TNS later as well, so I'm not going to talk in detail about that right now either. All right. So now, there we go. We've got this whole thing. So again, I really think the missing piece at this point is not so much any individual component, it's connecting them. And so that's what I want to show a little bit here is an idea that we're going to try to connect, say, the output from Antares and then go to all the way to an observation. So here I've put in the name of a candidate that I want to look for from ZTF. This happens to be a microlensing candidate, but could be any kind of multi-messenger follow-up target. It says, oh, this doesn't really exist in your TOM, so let's create a page for it. It does that, that's great. So it's now got a page, it's got a few of these different things off the top of the bat. You can already see kind of what the field looks like. You can see its coordinates. And then after that, we can then go, just like that, we can click a button, go to observations. So there's, it's going to broker, to say a TOM, to a telescope. So really trying to connect all these different ideas together. That's my slide. And then you finally get data. Very exciting. This is my own personal hobby horse, so I'm going to try not to talk too much about it, but I think one of the pieces that doesn't get talked about enough is once you get the data, you have to reduce it, but not only just reduce it, and by say, like some poor graduate student has 6 months and you say, good luck, here are 6 spectra, go write your thesis. If we're going to make decisions about this, we have to reduce things quickly. And we have to know we can trust those reductions as well. And so it really is an important thing for us to have well-trusted, robust, and standardized reduction tools for both imaging, photometry, and spectra. So these are some of the people who are starting to think about this. So the AstroPy packages have photutils and specutils, which are trying to standard this kind of at a community level. And then from the spectra, these are a couple of spectroscopic packages. One, Dragons, which is coming from Gemini, and Pipet, which is a very general use spectroscopy reduction toolkit. I'm of course going to take speaker's prerogative and talk about my favorite, which is Bonsai, because I wrote it. So Bonsai is the pipeline system that we use at Las Cumbres. I can tell you details ad nauseum about it, but it is set up to run fully without any humans in the loop. It's set up to be modular so that you plug and play individual different processing stages. The processing stages that are implemented are well tested, both in unit tests, so tests on, say, synthetic data, and then tests on real data using integration tests as well. The idea is, because of this, we want to go from data being taken on the telescope to being available to users within just a few minutes of shutter close. Oh, that's fine. And just a quick preview, talking about some of the different improved UI elements that we can talk about. This is something we've been working on, and that we're just getting ready to deploy in kind of a beta version in the next couple of weeks, is a reprocessing system for our low resolution spectrograph. So I can choose data that I pulled directly from the LCO archive. I can look at our arcs. You can kind of see, and if you recognize spectrograph formats, it's a little strange. It's a cross between it's a two order, a shell, plus a long slit. So it's a little interesting to do the data reduction. But then we can look at things like the wavelength calibration. We can look at the extraction regions. We can look at how the profile's been fit. And then the thing we've been working on recently is that we're able to manually update these different regions so that you can choose different regions to extract. So we have two orders, so it's a two order shell. We have a red and a blue order, which is shown here in the profiles. And then finally, we've got the extracted spectra. Now, this is something that traditionally we probably, at least in the US, done with IRAF. If you've been tried to install IRAF recently, you know that that's getting it. It's yes, it's both been a heroic effort by people like Oleg Stryker to put it into an installable state. So there is the IRAF community installable package now, which is fantastic. But there is very, very low level maintenance for this as well. So I would argue it is time to move forward with more modern tools like this. All of this works entirely on the web. You don't have to install anything. You pull in your data and then it just runs, and you don't have to worry about windowing. You don't have to worry about all these other issues that we've had for so many years. All right, so now we have, we've discovered something. We want to send something back into the system to tell astronomers, other astronomers, hey, oh, look, we found a new target. Where does that go? There's a couple of different places we can do that. One of which is you can write a GCN circular. This is the new interface for doing so. It's much improved over pretty recently over the old system. Similarly, we've designed a kind of a parallel system with SIMA. So this is the front end of SIMA. It reads in all the GCN notices, and then it can be used to write messages back as well. So there's a couple of things we've done here, one of which is we've tried to automate some of the common things that you would want to put in a messaging service. So perhaps you want to report a set of new candidates. You can automatically ingest those into a nice table such that it's an easily viewable format. You can then, of course, my movie play bar is covering what I need to see, but you can write a message to the universe or to other astronomers. Because though we've split this into a combination of machine readable and human readable text, you can do validation. Like I just flew through that the particular one had a mistake in it, and then right now you can actually see that it's gone the whole round trip through our system. So now you can actually see this. We have set up systems so it's both JSON readable, human readable, and it's all of the above. The other thing we've done is we've used it to connect to different services. Say you find a new target, if you submit a Hermes message, it'll actually can go create a TNS target name and do a TNS discovery report at the same time as you send a GCN circular about the targets as well. So there is a lot of different connections you can make through there. I'm running out of time, of course, but I'm actually getting pretty close to the end too, so that's good. We also designed this to be a way to share data between groups. Coordination requires data sharing, who knew? But it's not always easy to share data even between members of a small collaboration. You can imagine, you can think of the ways you've done it. You might have done email. You might have sent a Slack message and said, here, looks like curve. You do something that's a little more automated now. So this is the Supernova Exchange, which is the Global Supernova Project's specific instance of a TOM. And then this is a just a vanilla demo Tom that we set up. So we start, there's no data from this. And so I can go into SNEX and I can say I want to share this. In this particular instant, we're going to share to Hermes, which is nice because it also gives me the opportunity to share to multiple people if I want. I can say put that information down one of these streams. So here's the corresponding message, which is nice because I could say share this with dozens of groups if I wanted, anyone who is on this topic. And then I reload the other Tom, and which has been listening to that topic. And it should reload right there. This poor, yeah, right there showing we've been able to fully pull all that data in. The nice part about this is it solves one of the issues with sharing data is that if we all have disparate systems with disparate APIs set up, it becomes very difficult to try and share with everybody that you might be able to, you would want to share with. So it becomes an n squared problem. In fact, this pushes it back towards an n problem where you submit it once via the Hermes API, and then everybody who wants to implement that as a listener understands it's going to be on this common format, so they're all able to ingest it at the same time. All right, and I'll finish up by saying, humans can actually be a lot harder to coordinate than technology, but it's also extremely important. And so one of the things we've started at SIMA is we've restarted the Open MMA telecons. This is just a quick snapshot from our first one since we've restarted. It was about a week and a half ago. The next one is going to be early October. I think I need to double check the date, but I don't actually have to do that because you can sign up for it yourself and you can get reminders that don't require my brain to work at the same time. And to do that, the sign up process is now hopefully a little easier than it was. Is you go to the SIMA website, the front page, you click on, there's an Open MMA wiki, or you can subscribe to the mailing list. Under your account, you can click here, there's this Open MMA, and down here it said, would you like to subscribe to the Open MMA mailing list? So you'll get notices about this as well. We obviously don't want to take all the time, so we've actively set up a Google form where if you want to present your latest and greatest discovery, your latest and greatest piece of technology, whatever you'd like, at one of these telescons, I can, the link is rather long up here, but I can happily send the link along if you're interested. But there's a very simple way to request a slot at one of these upcoming telethons. With that, I'll leave you with my conclusions. I pulled out, this actually isn't even a fully comprehensive view of all of the different little logos for these different projects. And when I made this slide, it was really striking how many things have been built. And again, this is not even complete. So I think we're now at the phase where it's not only trying to build new tools, many of the tools have been built, but I think we really need to do a couple things, one of which is lower the barrier to entry to these tools so we get broader adoption so that people are willing and easily able to use these tools rather than reinvent their own, and therefore increase adoption. And then the other piece here is how do we integrate these tools? And I hope that these are some of the different questions that we can start working on this workshop. So I'm looking forward to it. Thanks.